Thank you for joining this lesson. Remember to subscribe to this channel and to also share the link with friends. We're going to discuss thermal radiation, which is a mode of heat transfer. Remember, there are three modes of heat transfer. We have thermal conduction, convection, then now we are having thermal radiation. So let us discuss thermal radiation. What you should know about thermal radiation is that this is the mode of heat transfer whereby heat is transferred through vacuum. In other words, matter is not involved because vacuum is the absence of matter. It is through this process of thermal radiation that radiant heat reaches the Earth's surface from the sun. Therefore, there are some applications of thermal radiation as we are going to see them. But on a nutshell, the process through which radiant heat from the sun reaches the Earth's surface is radiation. Even on a real life application, in case you're warming yourself using a flame, the flame which is hotter than you is going to release thermal radiation, which will reach your body through radiation because matter will not be involved in such a transmission. The higher the temperature of the body, the more the amount of thermal radiation. So if a body is very hot, or rather at a very high temperature, then it means it has what we call thermal radiation, and radiation from such a body to cooler bodies around it will take place. Therefore, the higher the temperature of a body, the more amount of thermal radiation the body has. Now that we are talking about thermal radiation, it's good we handle the two modes of heat transfer which take place, because when heat has been emitted from the object which is having a high thermal radiation, the same heat energy gets absorbed in another body of a lower thermal radiation. For example, the sun has very high thermal radiation. Therefore, it emits heat energy which gets absorbed by the bodies or the objects on the Earth's surface. Therefore, wherever there is emission, there is absorption of thermal radiation. In other words, the same heat gets absorbed by the cooler body. A good absorber of radiant heat is also a good emitter of radiant heat, while a poor absorber of radiant heat is also a poor emitter of radiant heat. It's very good to understand this statement. Very good to understand this statement. If an object or a body is a good emitter of radiant heat, it is also a good absorber of radiant heat. Let me give an example of two bodies, A and B. If we have an object here, which is let's say dull, and another one here, which is shiny, it's very good for you to know that this one absorbs thermal radiation at a faster rate than the shiny one. But now something else you should know is that if they are initially hot, the two bodies, if they are initially hot, now they will be emitting heat to the surrounding. Therefore, again, the one which is dull will also emit radiant heat at a faster rate than the shiny one. If you leave the two objects, let's say you leave them at 90 degrees Celsius, and also this one at 90 degrees Celsius temperature, then you give them some 20 minutes and you come to measure their temperatures after they have been cooling. You will discover that the dull object is at a lower temperature than the shiny one. This is to show that the rates of emission are different, and to conclude this, dull substances are good absorbers of radiant heat and also good emitters of the same heat. Shiny or highly polished objects are poor absorbers of radiant heat and also poor emitters of radiant heat. Let's consider a setup as shown here. we've been told that there is some hot water here. So if this is hot water, then it means now emission of radiant heat is going to take place. Now on this side, the surface is polished, while on the other surface, we have a painting of the surface being black. Then now we have this boiling tube A together with boiling tube B are both black. Therefore, their rate of absorption is going to be the same. What we are examining is the rate of emission from the two different surfaces of the beaker containing hot water. Therefore, we have a colored water in limb A and limb B. Then after some time, we are going to experience an observation. And what will happen is that the water in limb B is going to go downwards, while in limb A, the water level is going to rise. In case you are told in an exam to show the new levels, somewhere there, and this other one goes down to a new level there. Why is this happening? This is happening because the hot water here is getting emitted from two surfaces. There is a black surface which emits heat faster. So when this black surface here absorbs the heat from the black side of the beaker, the air inside is going to expand before this one absorbs heat and also expands. That means when air expands, it's going to push because of the increased volume out, so that the level of water is pumped downwards, resulting to a raise of the water level on the other limb. Therefore, the observation is that water in limb B goes down, while water in limb A will rise up. That is because the black side of the beaker, which is having hot water, will emit radiant heat faster than the polished surface. So this one is an experiment to show that different surfaces will have different rates of emission. But now we can have, before we look at the applications of thermal radiation, it's good we know that we can also have an experiment which is showing different rates of absorption, because this is dealing with different rates of emission. We can have a source of water here, not even a source of water, but a source of heat. Let's say this is a flame, it's a source of heat. Then at equal distances, you have a beaker, which is this is a black beaker, having some water, of course. Then there is a thermometer here. This is a thermometer. Inside is what we call water. This is B. Now on side A, at an equal distance, we can have an equal volume of water. But now this one can be a shiny beaker. This is also water of equal volume, initially at equal temperatures. And this is side A. Then you are told by an examiner for this case to state the thermometer, because now inside A we will still have thermometer. Let's say we have a thermometer here. So you are told to state the thermometer which will have a higher temperature after 10 minutes, the one which will have a higher temperature. Then we will say thermometer B. Thermometer B, or thermometer in B, will show thermometer in B. Thermometer in B will show or will record a higher temperature. Why does it happen so? This is because black surfaces absorb radiant heat at a faster rate than shiny surfaces. Therefore, the shiny beaker, even though it will still absorb radiant heat, it will be at a faster rate, at a slower rate than the black one, which absorbs very fast. Therefore, the thermometer here, thermometer in B, is going to record a higher temperature, and such other questions. So you should know that where radiant heat is involved, the rates of absorption are different, the rates of emission are different, with black or dull or dark surfaces being better absorbers and also better emitters than shiny or highly polished surfaces.